This is a total production. Hello surveyors, Dr. Nettles coming at you again. This is our second video for chapter 8. Here we're actually going to look at reactions where we can utilize either one of four possible ways where we can look and determine what in a reaction has been reduced, what has been oxidized. You may recall that one of the rules was looking at adding or removing hydrogen, right? If you add hydrogen, you tend to reduce. If you add oxygen to something, you tend to oxidize. That was the second way. And then the third and fourth ways are very interrelated about adding electrons, or how we increase or decrease their oxidation numbers. So even though the slides represent them as two separate ways, I kind of really consider them the same way. So really there's only three ways, but anyway. So firstly, let's look at what we have here. I want to try and go through all of the rules, and this first one is pretty much the only one that's going to easily allow me, per se, to go ahead and do that. So let's look at what we got here first. Alright, so we've got H2 plus O2 producing water. Alright, so if you notice, over here, oxygen gained hydrogens. So in this case, we would expect that oxygen, that's the element that was reduced. Right, vice versa, right, hydrogens, right, gained oxygen. So hydrogen was oxidized. Now, we can utilize the idea of oxidation numbers to also help us do this. So you don't always have to rely on just one way. Not always. So with this, right, we know that elemental forms like H2 and O2, those start out as oxidation numbers of 0. Now, when we go and look here, water is neutral overall, and so for hydrogen, right, its general rule is that it always becomes +1 when it's outside of its elemental form, and as long as it's not paired with a metal. Well, it's paired with oxygen, a non-metal. So here, hydrogen is +1, and then oxygen predominantly exists as a -2, right? As long as it's not a part of peroxide. It's called water. It's not called peroxide, right? So in this case, the oxygen is -2. So let's see what happened here. We can look at it from just what was added here, right? Oxygen was reduced because it got hydrogens. Hydrogen was oxidized because it got an oxygen. But also, if you look at oxygen, it goes from a 0 to a -2. So that means oxygen had to do what? Did it gain or lose electrons? It gained electrons, right? Hydrogen went from 0 to +1. So it lost electrons, right? So in the gaining and losing of those electrons, there's also a little saying. You can either use oil rig or Leo Gur. Leo the lion goes Gur. I'm old, so I use the Leo one. So Leo the lion goes Gur, right? And so these are acronyms for lose electrons, oxidized. Gain electrons, reduce. So if you look, gained electrons, right? That was the oxygen. It gained electrons. So therefore it was reduced. And that's the same deduction we made here in just looking at adding the hydrogens. Hydrogen here lost electrons. Lose electrons, oxidize. So that was oxidized. And you notice, right, we said hydrogen here gained oxygen, and it was oxidized, right, just from looking at it. But even using the oxidation numbers is helpful. All right, next up, here we have iron plus copper sulfate giving us iron sulfate and copper. So iron and copper here, right, by itself and by itself, those are elemental forms. So they go from 0, like they're 0 as I put above them. Now, both of these are sulfate, so nothing really happens with the sulfate. We didn't break apart the sulfate polyatomic ion. So I'm just going to ignore them for right now in terms of I'm not going to assign oxidation numbers for them. But if you look at the copper and you look at the iron here, right, copper, sulfate, that means that copper has a charge here. Right, sulfate has a -2 charge overall, so here with one copper it should be +2. Same thing with iron here, right? There's only one iron atom or one iron ion with the sulfate, so it should be +2. So let's look. Iron went from 0 to +2. So what does that mean? It lost electrons, right? So if it loses electrons, right? Leo, lose electrons, oxidize. So therefore, iron was oxidized. Here we have copper. It went from +2 to 0. So in order to do that, it had to gain electrons. right? And vice versa. The opposite of gained is, right, if you gain electrons, it's reduced. So I would put that copper was reduced. All right, next up we have iron and chlorine, both of which are in elemental forms, so these are easy, 0, 0. Makes iron 3 chloride, right? Because here the chlorine has a -1 charge, and there's 3 of them, so 3 times -1 means for this to be neutral, that has to be +3. So here iron goes from 0 to +3, and then chlorine goes from 0 to -1. So here iron lost electrons again, meaning it was oxidized, right? Leo, the line goes ger, lose electrons oxidized. And chlorine should do the opposite, right? So here it had to have gained electrons and become more negative. So you gain electrons reduced. Reduced. Okay. Next up, here we have zinc, HCl, so elemental zinc, that's 0. We have HCl, hydrochloric acid. And so here we would look at this from the rules, right? Chlorine as the ion form is -1. Hydrogen is typically +1, right? And hydrogen isn't paired with a metal, so of course it is +1. Here we have zinc chloride, so ionic compound. The chlorine is -1. So if you notice, chlorine doesn't change at all, right? Chlorine was -1, stayed -1. But here the zinc now has to be +2 to balance the two -1s. And then here hydrogen is elemental, so it's 0. So from here, what happens? Zinc, let's look at it first. Zinc goes from 0 to +2. So it lost electrons, right? And remember, Leo, lose electrons oxidized. So it was oxidized. Here, hydrogen, yes, hydrogen goes from +1 to 0. So it became less positive. So it had to gain electrons. So therefore, GER, G-E-R, gain electrons reduced. All right. And so that answers that one. What element was oxidized? What element was reduced? Next up, we have silver nitrate and nickel solid producing silver solid and nickel nitrate. So here you notice the nitrates didn't break apart. So I'm not going to assign oxidation numbers for those because nothing changed. Since nitrate stayed looking like nitrate, nothing happened with its electrons. Okay, but here we go from silver ion to silver solid. So elemental form for silver here is 0. Elemental form for nickel solid here is 0. So here, silver is a part of the ionic compound, silver nitrate. Nitrate has a -1 charge overall, so silver had to have a +1. Same thing here. Nickel has a -1 charge overall, and there's 2 of them, so here nickel had to have a +2. So if we look at what happens, silver goes from +1 to 0. So what does that mean? It gained electrons. Therefore, GER, G-E-R, it was reduced. Nickel, it went from 0 to +2. It lost electrons. So Leo, L-E-O, means that it was oxidized. That's what the O stands for. All right. And then next up, we have elemental potassium and elemental chlorine. So both of these are 0. And then we form this ionic compound. So here, potassium is +1, right? And that's all we really have to do is look at the periodic table and those ionic trends. And then chlorine is -1. So when we look, let's start with potassium since it's listed first from the left. It went from 0 to +1. So what happened to it? It lost electrons. So Leo, lose electrons oxidized. And then chlorine has to do the opposite. So it went from 0 to -1. I say it has to do the opposite because I've assigned one as being as oxidized. So the other one has to be reduced. You can't have 2 oxidations on 2 separate things, right? And then there's no reduction whatsoever. That doesn't happen. So 0 to -1 means it gained electrons. So the opposite effect did happen here, and therefore it is reduced, right? G-E-R, GER, gain electrons reduced. All right, so hopefully these 6 kind of help you practice. One, you see how quickly I assign those oxidation numbers, and if you can't do that, you need to go back and practice the first practice video for chapter 8. All right, but you see, if you can do that relatively quickly, then you can assign what element was oxidized and what element was reduced. All right. Anyway, so from there, adios. Until next time.